field classification. And all this is um, classifying soil by hand. So in the field, we don't have all the equipment that I showed you today, like the sieves and um, the hydrometers. Um, we don't have any, really don't have any of it in the field when we're looking at the soil for the first time. But there's either an engineer or a geologist that's looking at the soil and writing down what it is. So, and actually, I'm doing that next. I'm going to be out in the field with one of our staff engineers um, for a project next Tuesday. I might be teaching from. I'll be in Sylmar, so I don't know how that's going to work, but I'll figure it out. So, yeah, it's a project in the field where you're collecting soil samples as it comes up out of the ground. You're recording what type of material that is. And so today we're talking about how we do that, how it's recorded in the field. And then for the assignment, I'm going to ask you to go out, collect a sample, and record it in the field for yourself. So, and it's better to do it in the field because I don't bringing a bunch of dirt into the house might not be good. Just gets messy. But I would do it in my house. If you want to bring it inside to look at it, and actually collecting a bag of the material would be good, just to be able to look at it as you go through this. So yeah, the objectives are using the USCS and describing the characteristics using the field logging guide. And the two chapters in the lab manual that we're covering is chapter 2, again, the drilling and sampling. And appendix A has good information about the methods for describing soil. And then print a copy of the field logging guide. We're going to go into that in a little bit. So I've included the ASTM standard here for this. If you click on it, it opens up the ASTM, which is great because in practice, this is how you would have to do it in the lab. Sometimes we request the lab to do this classification, but it costs extra money, and geologists and most geotechnical engineers are trained at it, so we usually rely on them to do this. But if you ever wanted a refresher or the specifics about how it's classified, because just a standard approach to classifying, this is where you could start. Lots of different companies have their own terminology and things that they've been doing for years, but if you go to most agencies like Caltrans or LA or Army Corps, environmental, EPA, they follow the standard. So if it's not to the standard, they complain and mark up your field logs. So this goes into depth about what we're doing, and you don't have to read it necessarily, but if you have a question, before you ask me, I would ask your group first. That's like number one. I would say a lot of the questions that I heard I think probably could have been answered from the group. Like if you stepped away to do something and you missed part of the lecture or the Zoom meeting, then go to a group mate. Maybe somebody stuck around. So that would be the first step. Go to your teammates, your group. And the second step would be go to the material referenced on Blackboard. I try to put everything in there that you need to complete the assignment. Makes my life easier if you're able to find it. And then if you can't find it, yeah, feel free to email me. I don't mind getting the emails. It was just I can't always reply to them, I guess. This weekend was great. I had time to reply to emails, but a lot of times that's not the case. So let me plug in my computer here real quick. Okay, so the key, what to write down for all that, what I just said, is the ASTM standard. You don't have to read it. So maybe write ASTM D2488 is the standard. You don't have to read it, but use it as a reference because it goes into detail about everything that I'm talking about. All right. And then the next thing I would write down is the field logging guide. That has everything you need for this lab. You could do this entire lab by printing out these 2 pages of paper and going in your backyard, and you would be ready to go. Or if you don't have a backyard, go to the park or go on a hike or go in your planter box. Wherever you can find some soil. If there's a construction site and you can go ask to check out the soils for a class, I would do that. Don't say I sent you. But that might be a good place to see good engineering soil. Because if you do go in your planter, you're going to find good potting soil. But usually engineers rip all that out before they start working. And yeah, I guess environmental engineers too don't necessarily like organic soils because they tend to leach stuff. But anyway, write down field logging guide, and that is all you need. That is, download it, print it if you want. Just have it while you're doing this lab. Field logging guide. If you're thinking oh, maybe I should ask the professor this one thing over the weekend, just check your notes and be like, oh, the field logging guide, the answer's in there. All right, so that's all I'm going through today is the field logging guide. So hopefully this will be pretty easy.
Professor?
Yeah.
Sorry to cut you off. There was a question about if this lab is individual or still a group lab.
It's individual and group. Thank you for pointing that out. I didn't see that in the chat. Come on. Yeah, so it's individual and group. So I'm going to go into that, but every group member needs to classify the soil that they collect. And then the group assignment is to put it all together in a boring log. So I'm gonna go into that, but yeah, the answer is it's a group assignment, but every individual has to log a soil. So opening up the field logging guide, this is all you need here, and this is a revised. I revised this one over the weekend. So if you have the one in the book, it looks pretty much the same. I just changed some formatting stuff and misspellings, but it looks the same as this. And the most important part of this, I would say, is this section right here, this soil description. So if you're taking notes, write down soil description, and that's the starting point. So when you start at the soil description, you're going to see how to log a soil. This is how we do it in practice, and this is how you'll put it together for the assignment. In practice, it's not always this simple. A lot of times agencies want a lot more information, and for example, there's this one here. This was just on the desk here, because our lab technicians use this for their classification. This is the Kleinfelder version of the same thing that you have, but I don't know if you can see this table right here. That is the list that we go by for classifying soil. So in that list, there's like 19 different descriptions. And then for this class, all you're doing is 1, 2, 3, 4, 5, and maybe etc. 6. Let's say 6 descriptions. So it's kind of the simplified version with just the important stuff. Sometimes the other stuff is just extra, you don't even need it, but this is the important stuff that you need. So if you're taking notes, I would write down soil description. I wouldn't write down all this other stuff, because that's in the soil description. If you open this up and you print it, you will have it. So this is on Blackboard. You just need the field logging guide, and then you need to follow the soil description. So everybody in your group should have the same format, the same order. And the importance of that is that, like in practice, when you go out and you log your first soil, or maybe you're not a geotechnical engineer, which most likely, I don't know how many people are interested in geotechnical engineering yet. But if you're reading a geotechnical report and you go to the logs and you want to find out about some soil that's in them, it would be crazy if you got to the logs and all the information was given in different ways each time. I mean, you might be able to make it sound more beautiful, but the key to the soil description is that everybody says it the same exact way in the same exact order. So you have your group name, your symbol, and those are your introduction. In the example right here, below that it shows your group name is poorly graded sand, and your symbol is SP. And then you get into the description about that soil. So you start off with color. That's going to be the first thing. And then you're going to talk about the grain size. And by talk about, I mean like just list it. So I will get into that more once I get the soil sample out that I have here. Okay, then you're gonna list your moisture content of the soil, depending on where you got it, how deep you dug, or what type of soil it was. It could be dry or more moist. Especially if you're getting into this weekend, it's probably gonna get wet from the expected rain. Then you're gonna go into the density and consistency. Density is a term used for sand. Consistency is a term used for fine grained soils, and I will repeat that later. Then you'll have any other descriptors, etc. In this case, the other descriptors, etc., are they're saying slightly micaceous, which you don't have to know, and you don't have to write that. And a slight hydrocarbon odor. If you smell your soil and it smells bad, then you might just try describing what you smell. So now let's jump into each of those real quick. So for the group name, you can see that in the example is poorly graded sand. Where the group name comes from is directly below in the United Soil Classification System, or USCS for abbreviation. So you'll see in that table right below the soil description has every single type of soil per that classification system. And that's what engineers use, and that's soil scientists use another version, but this is the one you'll be using. So the group name is described over here to the right-hand side. You'll see different descriptions of the different types of soil, depending on how fine or coarse your material is. And I will get into that when I get out the samples, but the names are based on the grain size. And also you'll see it's based on the liquid limit, which we can't do in the field. So we have to estimate this. And I'll show you kind of how we do that. So you're going to start off with that, the group name, or you might end with that and come back to it, but it's got to be in the same spot on the description. And then the symbol, that's this right here, this row, this column. Your symbol in the example is SP, which you can see down here, SP, and it stands for poorly graded sands. It also stands for gravelly sands, but it's here called the poorly graded sand, which is good. All right, now I'm going to color. The color is listed off here to the right. For color descriptors, your soil needs to be wet. So you're going to need a little bottle of water, a spray bottle, if you have a water or hairspray bottle, or just a cup of water. Bring that out with you so that you can get your sample moist to classify the color. And you'll see if your soil is dry and you get it moist, it's going to like drastically change color. I don't know if anybody's noticed that before, but when soil gets wet, it changes color drastically. And so the standard convention is to classify it when it's moist. So then the next one is grain size. For that one, you're going to be flipping over, or in this case, scrolling down to the next page. So grain size is on page 2. And you'll see the table that says grain size. So if you have, this is important if you have gravel or sand. If you don't have gravel or sand and you just have a lot of fine material, then it's pretty straightforward, just fines. But if you have gravel or sand, there's different sizes of gravel and sand, and it's listed here as the size in inches, and then the sieve size, which the sieve size won't make any sense to you right now. Maybe not, maybe it will, but we don't have sieves in the field, so we either use the dimensions. Like if I see a rock that's 8 inches in my sample, it's going to be considered a what? Can somebody tell from this table what an 8-inch rock would be considered?
Cobble.
Yeah. So, if you find a cobble in your soil, that would be a descriptor. If you find smaller diameter rocks, anywhere from 3 inches to 3/4 inch, then you're looking at coarse grain gravel. And then there is fine grain gravel here, which is 3/4 to number 4. And this is where this little chart on the side helps the circles. So if you print this out, it's hopefully to scale. And this, if you lay your rock or your sand particle there on top of the paper, you'll be able to see if it's 3/4 inch or number 4 sieve size, or number 10 sieve size, or number 40 sieve size. If you can break it down into that smaller size, it helps you come up with, determine whether it's coarse or fine. So that's your grain size. Then moisture content, I've changed it in this one because the other version of this used somebody else's reference, but the standard, it didn't use the standard convention. So some geotechnical companies use different language for the moisture content, but the standard convention is dry, moist, or wet. So if it's in between those, the appropriate way to label them is dry to moist or moist to wet. And then there's a description of what those different labels mean, but don't get too wrapped up in it. It's just, is it dry, or does it feel really wet? Is there water just all over, or is it have a little bit of moisture? So don't get too wrapped up in that moisture classification. Dry, moist, or wet. And then, all right, moving to pretty much the last one. The other descriptors are going to be tough, but we'll talk about them briefly. So the density, consistency, those are 2 different things for 2 different types of soil. So if you're making notes right now, write down this. Density is a term used for sand or coarse grain soil. write down that density is for coarse grain soil. And it says it up here, but I don't know, for some reason it gets confused. So density is for coarse grain soil like sand and gravel. Consistency is a term for fine grain soil like silt and clay. So that was the other thing to write down is consistency is for fine grain soil. So depending on what type of soil you have, you can describe the strength relative to the density or relative to its consistency. So for fine grain soils, it's much easier to do in your hand. It gives you the description of how to do it right here. You don't need the blow count necessarily, because when you dig up that soil, you'll be able to still feel how the consistency of it. If it's like a clay ball that you dug up out of your yard and it's really soft, you can push your finger into it, then it's going to be very soft. If you're having to get like a pick or something to get the soil out, which I don't want you to do, you just if you can't dig it out with whatever tool you're using, then don't worry about it. Just call it very hard, and then spray the ground with water and get your color from looking at the ground itself.
Professor?
Yeah, it's up.
Sorry to cut you off. I had a quick question. For those classifications, are we to do those tests when the certain sample is moist after we put water on it, or when it's dry?
This is in situ, so this is not changing the moisture. So normally what we do in practice is the sample is getting driven, is being collected by driving the split spoon into the ground, and we count how many blows it takes for that sample to get hammered into the ground. And I'm hoping I can share that with you next week, because I have to go to the field on Tuesday, and I'll record them doing that work, and I'll post it next week, so you get to see it. Not now, but so we're recording the blow count, which gives you an indication of how hard it is in place. So with clays, a lot of times that blow count, if it's really dry soil, we expect that blow count is going to be off, and the soil gets hard as it dries out. So if you got the soil wet, it might make it more soft. So it's an in situ classification. If you want to write this down, you write down that you moisten the sample for color, and that's it. So all these other tests are descriptions looking at the in situ state of the soil.
Professor, sir, if the soil is already wet, we have to wait for it to dry, and then we can calculate, and then just get the color off of it when it was wet, or how does that work?
So in situ meaning that it's whatever the moisture content is in the field, that gets recorded as the moisture content. So that gives you an indication as an engineer, like what you can expect that soil to behave like. If it's really wet, we expect to maybe be softer as you're hammering into it. But if it's dry, we know that it's it could, if it's a fine grain soil, it could be harder. So you're recording the moisture content as it is in the field. You're not adding water. You're just taking the moisture. You're looking at your sample, and figuring out what the moisture content is, and then the density and consistency. Since you don't have a hammer to sample it, you can use, for fine grains, you can use this description. And then for coarse grains like sand and gravel, it's going to be more difficult to do because it's only based on the sampler. But I would like you to come up with a determination based on your digging effort for the density. If it's a coarse grain soil, if it's sand or gravel, it's probably not going to be gravel. There's very few sites that are just like straight gravels. You got to be like in a riverbed or something. So if you're at your house or you're on a hike, maybe don't stop in the riverbed to take your sample. So I doubt it's going to be like straight gravels, and those would be really hard to classify. The density of it. But for sands, I think everybody's kind of got a feel for dense and loose sands. And like if you've been to the beach. I mean, we live in California, so I think we live in California. I don't know if everybody else is here. We're all online, so maybe you're not living in California. But we live by the beach, and hopefully you've got to play with sand before, and you'll see that like the dig it and it's loose, so you could say it was loose or very loose. But then as you dig down deeper in the sand, what happens is like I don't know if I remember as a kid like digging tunnels in the sand with my hand, and eventually your fingers just can't penetrate through the sand, and that would be more dense soil or dense sand. So judging by like how much effort you're using to dig the soil, you can determine the density of your material. And then if you have a fine grain soil, like silt or clay, you can use the description here. So like the example I gave was if you have a soft ball of clay, you can squish your thumb into it, it's very soft. So it says thumb penetrates easily. And then it has these other more specific, thumb will penetrate about 25 millimeters, which is, I mean, what is that, an inch? So to me, that's still pretty soft. But I don't know. So it's going to be soft or very soft. And then medium, you're not going to be able to penetrate with your finger very far. It'll have resistance, but it'll still be enough to squeeze the soil. And then a stiff sample, it just indents it. Maybe you can see your fingerprint there or something. And that's confusing to me that penetrate 12 millimeters with great effort. And then the hard, you're not going to be able to indent it with your thumb, but your fingernail might still go into it. And then very hard, you probably won't even be able to indent it with your fingernail. So those are different ways for fine grain soils. So maybe write down for density of sand. You could write to use the digging effort to determine the density. And then if you want to write down For consistency, use the description of the thumb penetration. Okay, and that's pretty much those are like the four main things that we classify in the field: the color, the grain size, the moisture, and the density consistency. The other descriptors, etc., those are more geologist type things. Maybe I'll be able to pick some out in our samples today, but there's some more information in the back, second page here, about odor and other descriptors. Like I said, you don't have to know these. If you see something different or interesting about your soil and you're wondering what it is, feel free to take a picture and ask, or look it up. But I don't expect you to know what iron oxide staining is, or micaceous soil is, or carbonate stringers are, or caliche. If you get into geotechnical engineering, you will get to learn all of that. And it's really fun. It's like cool looking when you see stuff like that underground. So that is all, I believe. Oh, the grain shape is another good one. I don't know why that's not in there. The grain shape is important. It tells like a story about how your soil was deposited. So if it's more angular, likely like fell off of a cliff and just ended up there. But if it's more rounded, it likely got washed in a stream and ended up farther down the alluvial channel. All right, so I think we need to get started on some classification. This area is where people are going to get stuck. You're going to have coarse grain soils. That's really easy, right? Like, you know what the difference is between a gravel and a sand. Gravels are bigger rocks. Sands are smaller particles, but they're still like small rocks. But then when you get into silts and clays, it's classified by the liquid limit, which nobody knows what the liquid limit is right now, I don't think. I don't think if you have got there in class, maybe you're just touching on it. Those are the Atterberg limits. Has anybody learned about those yet?
No.
Okay. It's coming very soon. You're going to learn about the liquid limit soon, but we don't have the equipment to test the liquid limit in class, or not in class, in the field. So it will get confusing here, and I've asked, they hooked me up with some soil today. I asked that they give me samples of a more sandy, silty soil and a more clay soil, so I can help you understand where to go with those two. And the first sample they gave me right here, I thought it was pretty cool. They probably did this on purpose because it was me, but they gave me a sample that I collected like 2 years ago. I don't know if you can see that. It says HT 82318. This is for a project in Los Angeles, LAGWP, the Van Norman complex. It's the what do they call that? The LA County Reservoir. there's a famous dam there, and they're still working on that reservoir. And they actually had a failure. I worked on there. The dam failed. Oh wow, that's cool. This is the kind of cool stuff I'm talking about. Like, if you get into this field, I mean, the depth of this was at 65 feet below the ground surface. So 65 feet, that's like 6 stories down. And there's this. So I don't know. I think this is kind of neat because it describes a whole different color. Like, you can see the colors up there, and looking at the sample, I can probably pick out like 5 of those colors in this one sample. So hopefully your sample isn't that tricky to label. Anyway, this is what the sample comes like, what it looks like. You can see the ends have been sealed with electrical tape. And what that does is it seals in the moisture. So even though this sample was collected 2 years ago.
Yeah, I was gonna say it looks kind of wet.
Yeah. So even it's dried out a little bit, but by taping it up, it helps keep the moisture in there. And so when you get it back to the lab, you can test the moisture without losing it. So it's inside of here, but it's inside a set of rings in here. So if I take it out like this, actually, let me switch over to my phone screen. I think we can stop sharing. I want to keep sharing, but I want to also show the soil now. All right, so I'm sharing my spoon now. So if you go out into the field, you'll need, if you go in the field, meaning your backyard or wherever, you'll need your water. It doesn't have to be in a fancy bottle, it can be in just a cup. And then you'll need something to dig with. I've got this spoon here, but it doesn't have to be a spoon. You could dig with this side of the spoon, or you could dig with your hand if it's soft enough, or another tool. Maybe try to find a tool that you can use to dig. Okay, so back to the sample. So it comes as this container, but inside the container, these rings. And you can see there's still like free water in this. So it's probably a sample that was below groundwater, which is pretty famous. If you look up this dam, if you Google Dan Norman Dam or something, it's a famous dam because it failed from liquefaction. So it had shallow groundwater, and the soil is liquefied, and half of the dam sloughed off. So kind of cool place. But it changes from this more coarse material, and by the end of the other side of the sample, it's this finer grain material. This is like coarse material. It's definitely, we can tell it's a sand. You might think it's a gravel because there's like larger particles in there, but go to your table in the back of the field logging guide and look at the particle sizes that describe sands and gravels, and you'll see that these size particles are probably coarse grain sands. I can show you on mine. This is the Kleinfelder version. So using that guide, it's a little bit larger than the coarse grain. I'm putting it next to that circle that shows coarse grain sand. So it's a little bit larger. That might be in the pea gravel size or fine gravel. So and then breaking up the sample and rubbing it between your fingers, you can collect some of the finer particles. And you can see that my fingers are kind of getting dirty. That's just finer material. So it's probably some silt. Raw sand. And the important thing here, one of the important things that to point out is that, so in the field, I would log this as a poorly graded sand. It's all about the same size. There's smaller particles, but it's mostly the same size particles. They wouldn't classify for a well-graded sand, which you'll learn more about. But when it goes back to the lab, when they run their test, they're going to be mixing this sand with that sand and classifying the two together. So they might call it a well-graded sand after that, after mixing it. So one of the reasons that classifying it in the field is important. All right. So there's the sandy sample and an example of soil in this is a split spoon sample, the California sampler. That's what they come out as. It's this little 1-inch ring. We'll use these more in this lab. But I think that was an easier one. And I guess let me bring up the next two. So the next two I have are these bulk bags. And can you hear me while I'm talking over here? I've got my...
We can hear you.
Yeah, we can hear you.
Okay, so this was collected in the City of Ontario. Roadway construction on Archibald. And this one is from Target and Garden Grove. So the two Garden Grove, the material description is olive brown clay sand. And City of Ontario is described as silky sand. Just looking at these two samples, which one looks like clay and which one looks like silky?
Maybe the dark one is clay.
Yeah, I agree. But it's kind of hard to tell. Let's take them out. So, here in your backyard, what you're digging, that's what it's going to look like. I'm going to just set it down there. So for determining sorry. This is just real quick to finish up with the logging. So if you had either one of these, it would be hard to say whether each one was a silty sand or a clay sand, I feel like. And they're both moist, so that helps. But if you're starting out with a dry sample, it would help to get it wet before starting the classification. But since they're both moist, there's a couple like key things going on. From this sample, that the dark sample that you thought was maybe clay, it has these little nuggets in it, these harder materials that are kind of hard to crush. And that's what I was talking about where you're classifying consistency. That would be that little chunk right there, at least. Not the whole thing in general. It's hard to classify that. You almost have to do it while it's still in the ground and confined, because once you pull it up, that's hard to say if it's soft or loose or whatnot. So maybe pushing on it in the ground and using your thumb to indent the soil while it's still in the ground. But otherwise, you have, if you pull out a sample like this and you have chunks and you can use those to help determine the consistency, I would say these are like medium on the consistency scale. Remember, it goes like soft, very soft, medium, stiff, very stiff and hard. So to me, my fingers can push these together. So yeah, that to me, this is more of a clay. It's already like sticking together in chunks. Whereas if you look at this sample, see the chunk there, it doesn't stick together necessarily. Oh, here's a piece that's stuck together. It's totally different inside the, it's kind of hardened, it's a cemented like gravel. But the other pieces, it still has about the same moisture to it, but when it crushes, it falls apart. So there's a couple ways to tell, but then the other way to tell would be to get the two samples wet. So this is why you might want to do it outside. So you don't get inside your house messy. Or your apartment. All right, so we'll start out with the one that we thought was more silty, because that one is going to leave less of a mess, I think. So it forms a ball when you get it wet, but then when you squeeze it, it kind of falls apart. And that's kind of indicative that it has less cohesion. The particles aren't sticking together. When you try to roll it, it kind of just falls apart. It doesn't really roll into anything. Kind of just smears. So that means it has less cohesion. The particles are a little bit bigger in this case, and they would be considered more silty. Whereas in this one, it looks a little bit clayier. We had like those clay balls inside, but let's see how true that is. Maybe it's. I can already feel the difference in my hand, so you'll be able to feel the difference. And then if you have some sidewalk around and you get it moist, you'll see that this one kind of rolls together a lot easier. Whereas that one falls apart. So the samples sticking together like that indicates that there's more cohesion. The particles are really small, and they get held together by the water molecules, and that's typical for clay. So when you're testing your two samples, this is probably the worst case of either one, because they're like, this one is very on the limit of a plastic silt, I would say. I mean, it still like holds together in a ball. It's just when I try to roll it, it falls apart. And then this one's just barely a clay soil, but it has clay in it. So it's probably like a sandy clay. But when you get to that point, when you're stuck, like if you don't have a sand or a gravel, you have a more silty or clay soil, and you're in that field logging guide, it just gives you the liquid limit. This is one test you can do. There's other tests you can do, kind of outlined in the back of the book. There's the dilatancy test, which works for clay soils. So if you took your sample and then you tap it. Did you see that transformation? Did we see that?
Yes.
So the silty soil, it's kind of looks like that, and then I tap it a little bit, and it has all this free water that comes out. So you'll read about that in your Appendix A. It's called dilatancy, where if I did that with the clay soil, nothing would happen. So here's the same thing with the clay soil, and I can have it as hard as I want, and it doesn't. I guess this one gets a little bit more moist, but not much, and that's because the clay particles are better at holding onto the water. The silt just kind of lets it go. That's it.
Professor,
Yeah.
a quick question. You said that free water comes out. Does that mean for clay because it's more cohesive, less water comes out when you tap it?
Yeah. So for a clay, when I tapped it there, less water came out, and it's just because the water is being held together better, or held by the soil better. Whereas with the silt, there's less space for the water to hold onto, and it just kind of comes out of the soil. Let me wash my hands real quick, and then I'm going to show you. Actually, I just need to. Yeah, let me wash my hands real quick so I can pick up the phone and show you a couple more things that I see here that might be interesting. So there's a couple other things that I saw. Seeing if you can see them through the camera. It's hard to see through the camera. There's small. There. That tiny little speck there, and it's kind of, for me, it's shimmering. It's shining back at me. Those are little platelets of mica. Which is, I think we talked, or I mentioned it, where I said that one of the other descriptors is micaceous. So mica is an element, or not an element. It is a what is it?
Mineral?
Mineral, thank you. As a mineral, and you probably learned about it if you took the geologic engineering class. They form platelets, and when they get washed out into the alluvium, the platelets break up and they just become shiny little specks in the soil. So that was one thing I saw that could be another classifier for this. And then the other thing was in this soil. I don't see any more of it. But there was a little, like a root, which would be something else to mention. If you have roots, that would be another descriptor. All right. Fine.
Is that because roots follow the water?
It's just, I think it more means that it's closer to the surface. Roots do follow water, but if you're digging near the surface, it's likely that you're going to find roots. So I expect that probably everybody is going to find roots in their samples. The sample that I had in this tube at 65 feet, if there was a root in there, which you can find roots very deep, it would be just like a ancient root, fossilized root, something that's been buried for a long time. In Huntington, if you drill in like Huntington, Newport area, you'll see roots and seashells and seaweed buried hundreds of feet down. But yeah, in the backyard or wherever you're digging at, if you're near the surface, you're probably going to come upon some roots from plants around you. I think that's it. Let me just check the. So we talked about sand and gravel. I think that'll be easy. It's depending on the size. But silt and clay is going to be more difficult. And you can use the ASTM or Appendix A to help with that. Okay, so that was it for the field logging guide. So everybody should do that with a sample. You should log the soil. I'm leaving from my phone. All right, so you should log the soil from the field logging guide, but then every group has to turn in all the logs from everybody. And so what I'd like for everybody to do, if you have a camera or your phone, is take a picture of your sample and include that with your boring log. So we can come back to that and see what it looks like if there's any questions about what soil type you had. So the submittal that you're turning in will include the boring logs and the photo from each sample. So let me get into the boring log real quick. Is everybody still awake?
Yeah.
All right. Not too much longer. All right. So for the boring log, all this information is important for a regular field exploration. So I would like you to fill out the boring log to the best of your ability. For the project, this will be for our project assignment. So you can write the project name from the assignment there. For the project number that's listed under the project assignment. The client is listed in the project assignment folder. And the address, you can use either the address or the coordinates that are given. This is how we tell the sites apart. And I also included an example here to show you, like, this is one that I think I logged this one from LA. So the project location, and project number are usually all included. All I see is the consultant number here. Consultant project number. So yeah, in any boring log, those are included to help identify the site. Then logged by will be, it could be the initials from your group members. The drill crew could also be the initials from your group members because you're the ones drilling. You're digging these soils by hand. In the example log, the driller was Jet Drilling, which is one of my favorite drillers. They're fun people to work with. And then the USA ticket number, I don't know if that's included in the project description, but you can make this up. So if you're taking notes, write USA ticket number, make it up. It doesn't matter, but it should be included in the boring log. When you started it, when it was completed, and when it was backfilled, it's going to be different for everybody because each one of you will be collecting a sample from the backyard or from a hike somewhere or wherever you get your sample. So when you start and when you finish and when you backfill will all be different. So just whoever's filling it out, use the time that you started and completed and backfilled the hole that you made. It'll be a date and a time maybe. Then the groundwater depth, that was part of the last lab. You look up the groundwater depth for our project site. So you should be able to write the groundwater depth here for the project. The boring number is going to be just whatever you want to assign it. Usually we label borings with a B for boring, and then a number, numerical order. So it would be like B1, or sometimes for this type of boring that you're doing, it's called a test pit. So you're digging it by hand, and you would refer to that as maybe a TP1 for test pit 1. Then the drill rig type, you can either write a drill rig type in here from your book, or you can say that it was hand excavated. For the diameter, you can look up again from your book, either the lab manual has the diameter that we use in the field, or your textbook has different diameters for different drill rig types. If it's a test pit, you can just put the size of your hole that you dug there. The hammer drop, this is a very important one, but it's not going to be you don't have a hammer to run this test, but you need to know about different hammer types. You need to know about different hammer weights, and you need to know about different hammer drops for both for your lecture class, but also for your PE engineering exam. They will, and possibly your FE too. They might ask you about. Yeah, I'm not sure if it's in the FE. I know it's in the PE. They will ask you about hammer types, the weight, and the drop. It's a standardized weight and drop. So if you're taking notes, write down to look up the hammer type, the hammer weight, and the hammer drop. You can use either the standard hammer weight and drop, or if you're using your lab manual, there's a CPP test that we use, and that has the hammer weight and drop in there. I would use the standard if I were you, because then you know it, and you used it, and it'll be on your exam. So then you'll have some familiarity.
Where can we find the standard one?
Standard one is going to be in, I think it might be talked about in the lab manual, but it's definitely in your textbook. On that the same chapters that I talked about in the last lab, chapter 3, it was for Caduto, I think, for sampling, and then for DOS, it was either 17 or 18, depending on which edition you had.
Okay.
So it'll give you that information in there for sure. I know it will, because it's important in practice. It's like standardized across the world. Everybody uses the same weight and drop. Except in other countries, they use a drop in millimeters or centimeters, and we use inches. So there's that difference. The elevation. This elevation should be from Google Earth for your project site. So don't give me the elevation of your house. Put the elevation down for the project. And then the total depth of boring will just be, it can be the depth that you planned to excavate from your last lab. So if you planned to dig 20 feet, then you could put 20 feet here. If you plan to dig 50 feet, you could put 50 feet here. And then going into the next part, you have this this box here that has a bunch of reminders about the group name, and then the example that this is from the field logging guide. So usually we print this out and write on it in the field, and then there's this example. It's the same thing in the boring log. This is an actual LAD WP boring log. They require that you use this format, but you can see it's got the way they want the order of everything. So it'll type, color, particle size, and then it goes into all the other stuff. Angularity, structure, geologic origin. So it's on this one too, but it's based on your field logging guide. So that will be the description here. What I'd like for you to do is, when you start out these, let's say your samples are all going to be from the surface. Everybody's going to, I hope you're not going to dig 10 feet to collect your sample. Just go out to dig as little as possible to get your sample. But when you come back here and you're putting it on the boring log, spread them out the way you would spread out, the way you planned to sample. So if you plan to take samples at 3 feet and at 9 feet and 12 feet, you could spread them out that way. So it would be like sample 1, say 6 feet, sample 2, and 9 feet, sample. If that's the way you planned to collect your samples, you might have said maybe you plan to take them at 5 feet and at 10 feet and at 15 feet. That's how I would have planned it. But so the depth over here, that represents how deep the sample is collected normally. So we're just making it up for this class. We all collected it from the surface, but we're writing it down at different depths that we planned for. So your sample type, for all of them, it's going to be a little B for a small bulk sample. Or you can use that logo there. Your sample number, this was sample number 1, this was sample number 2, and this was sample number 3. Your blow counts per foot is, God, it's so important. There's a lot of important stuff in this class, but I know that this one, it's like always on the PE. It's just an easy question. So it says blows per foot here. I need to change that. Blows per 6 inches. So when the sampler gets driven into the ground, it's driven into the ground 18 inches. And they record the blows every 6 inches. So if you look at the example, you'll see the blows per 6 inches here. So you end up recording all these blows for every 6 inches. And that's like the N60 value, it'll be on the PE. So I want you to include it here, but we're kind of making it up. So you're including it, but make it up. You can use, depending on your density consistency, there's the blows correlate to that if you want to use that, or if you just want to make one up, I'm cool with that too. But as long as you know that there's 3 collected for each sample, it's very important. And more importantly, when you go to the PE exam, they're going to ask you, based on this blow count of 3, 4, 4, what is your N60 value? So you're going to have to come up with the N60 value, or they might even ask you, what is the N value? The N value would be like the easy question to answer. That's just the sum of the last 2 blows, so it would be 8. The N60 value is more complicated. You have to do a calculation based on the depth and the size of the boring and whatnot. But anyway, just make up some blow counts or correlate it to the density if you'd like. The graphic log isn't necessary, but you can see there's these graphic logs over here that are like kind of drag and drop. If you want to use these different log types. I don't really like them necessarily. You don't have to use that. Okay, so then when you get into your log, you write down, you don't have to write down what sample it is because you already wrote that down over here. But I want each person to participate in this lab. So let's say, Alejandro, you're collecting this first sample. So it'll be Alejandro. And then you'll start the group name, maybe sand. And then your descriptors. So then I'll be able to see who collected that sample, and then your photo of the sample, so I can kind of see the particle sizes and what your sample looked like. This last part, if you want to write down in your notes that you do not need to fill out the dry density, you do not need to fill out the moisture content or additional test. Those are filled out later. If you look at the example, it has moisture, consistency, and density, and LADWP has you write down the abbreviation for those, which it's kind of helpful, but usually we write it down in the description, so it's redundant there. So in the description here, you're writing down moisture, density, consistency. So what this one's for is more for like after we do the lab and you're getting ready to submit this in your project, you're gonna have to go back and fill these in based on the lab test we do to come up with the dry density and moisture content. So just in your notes, just write density, moisture content, additional tests not needed. Yeah, that was a lot to go over. Maybe I'll be able to put something together in the next couple of days to help recap all that information, but just go through it. If you have any questions, let me know. Shoot me an email, and maybe start. We can start a discussion board on it, so that any question that gets brought up, I can answer it, and it goes out to everybody. Does that work? Okay.
That sounds good.
Yeah.
I think that's it. I'm sorry. That was a long